Okay, here's an example for you. Here's the matrix A. I want to find the dimension of the column space. So the first thing I need to do is find a basis of the column space. Now, you may or may not have done this as an exercise in a preceding lecture video. But in any case, the answer we found is the first, third, and fifth columns. So presumably, if you reduce this matrix, you're going to find there's a pivot in this column, and in this column. Now, that says our basis is this guy right here. And easy as can be, the dimension of this column space will be 3. Okay, now let's look at a example where we find dimension of a null space. So find dim null A for, okay, what's the matrix? Let's think of a nice 3x3 matrix. How about 1, 4, minus 2? Okay, that seems good. I'm just making this up as I go along. You may have noticed. And then I will do minus 2, minus 8, 4. To make sure I didn't completely butcher that. Okay, yeah, that would be a good example. Now, first thing I need to do is find a basis of null A. So my procedure there is to put A into a matrix like this. And if I row reduce that, if I do, let's see, row 2 minus 3, row 1, and row 3 plus 2, row 1, I get 1, 4, minus 2, and everything else is zeros, beautiful zeros. Now, what does this say? Well, I have some variables I need to choose, so I'll go x, y, and z. So I get x plus 4y minus 2z is equal to 0. So x is equal to 2z minus 4y. Throwing that into my generic vector x, y, z, I get 2z minus 4y, y, z. Finally pulling this apart, I get y minus 4, 1, 0 plus z, 2, 0, 1. All right, let's see how I did. So I'm going to just quickly double check my answer here. What I'm doing is I'm checking that this matrix times this guy gives 0. And I'm checking mentally that this matrix times this guy is also 0. I am satisfied that that's worked out. So my basis is the collection of two vectors, kaboom and kaboom. So my basis has two vectors, so the dimension of the null space of A is